Okay, the quadratic formula. So let's look at what we're going to deal with the quadratic formula, which are functions that have this form. So we have a second degree polynomial with undetermined coefficients right now. So all of these functions have descending powers of x, and b can be 0, but a has to be some number. It can't be 0. If it's 0, this term goes away and it's just a line. And so if we graphically look at all of these functions, I'll draw two sets of axes here. And we'll focus on the value of a. If a is greater than 0, they have three forms. But they all are parabolas that arc upwards. Right? And they all look sort of like this. Now, why we like these functions is they have vertexes. They have some minimal value. And if we look at a being less than 0, we've got three forms they could take also. And they have some maximum. Their vertexes are a maximum. And so we use these as models a lot of times when we have things that we know have a max and min. And these functions can describe it. What is of interest is what happens when we set it equal to 0, when the output of the function is 0. And what we get are these places where it crosses or touches the x-axis. And these are called the solutions or roots. And so notice these two have solutions or roots. This one doesn't. But we can find these solutions or roots, and these will be imaginary. Right, I'll just put ing for, whoops, how did that switch over? It looks like I changed my pen here. Let me see if I can get back to the pen I had before. Nope, that's a big one. Change my computer, and now I have to get my software doing what I had it doing before. So yeah, there we go. So those will be imaginary, and the ones here will be imaginary roots. Now the fundamental theorem of calculus, or not calculus, algebra, says that a polynomial will have as many solutions as its degree. And a solution is when the polynomial is equal to 0, or when it crosses the x-axis. This one has one root, but it's repeated twice. And so to see what this looks like mathematically within the mathematical symbols is I could have a polynomial, or a quadratic polynomial, quadratic, x squared minus 5x plus 6 equals 0. And we're hoping that if it had a root or solution, it came from something where I had x plus or minus a times x plus or minus b equals 0. I should put capitals here because these are not the same a and b as in the quadratic equation. And the approach we tend to go to is we factor this. And we realize that the first term always gives me this. The first term of FOILing gives me this, and the last term gives me this. But this middle term is a combination of the outers and inners. And so what we end up doing is we look for some factors of this that will add up to this. And so in this case, this was x. minus 3 times x minus 2. And we say this has solutions where x equals 3 and x equals 2. Because that's what each of these factors solve towards. And this works really, really great if these are integers. But if they're not integers, there's still solutions. There's things with real numbers, and we need to find the imaginary. So if I look at a quadratic function that I've set equal to 0, so we'll say a quadratic equation, I want to find something that will give me answers for all of these, including if the answers are going to be imaginary. So what I'm going to do is I'm going to use the rules of algebra to manipulate this so I get some formula for x. So I don't like there being an a here, so I'm going to divide everything by a. And I'm going to focus on getting x on its own, so I'm going to subtract c over a from this side. Well, because this is squared, I'm going to use a process called completing the square. So a perfect square would have this form. And this isn't this c, this is just something different than these letters. Or if it was negative, it would have this form. Whoops, minus sign. And so what I want to do is to get this side into this form. Plus c squared, plus c squared. And so I notice I have these first two parts. Well, this thing here is the same as this whole thing here. And notice that's twice this. So what I'm going to do is I'm going to divide this by 2, and then I'm going to square it like it's squared over here. And I'll add it onto the end. So if I divide it by 2 and square it, there I've divided it by 2. I've almost divided it by 2, and I've squared it. But if I add something to this side, to keep this whole expression equal, this whole equation equal, I have to add it to this side. All right, well, I'm going to leave the left-hand side alone for a second here, and I'm going to clean up the right-hand side. So if I square this, this is b squared over 4a squared. Minus c over a. Now the left-hand side, I forced to be a perfect square. So I know it looks like this. And in our case, that's x plus b over 2a. Quantity squared. All right, let's again do a little cleanup here. I have a common denominator that I need to find. Well, this has a squared and a 4. So I need to multiply this by 4a. So keeping the right-hand side the same. If I multiply this by 4a, I get minus 4ac. All over 4a squared. We'll scroll down a bit here. If I take the square root, I get this all on its own. and I have to take the square root of the right-hand side. Now, whenever we take a square root, we have to get positive and negative values. So I'll put all of this here. And I'll work on simplifying this. So I'll put the plus or minus here. And the thing to note is in the denominator, well, I can take the square root of that. And the square root of that is 2a. Now the last thing I have to do now is solve for x by subtracting b over 2a from both sides. Well, this does have a common denominator of 2a. So I can write this in a really compact form. I can say x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so this will give me all of the roots from a quadratic equation if I focus on the coefficients. And what's nice here is this square root thing, this b squared minus 4ac, can tell me some information. If it's greater than 0, I get 2 real solutions. And if it's equal to 0, I get 1 real solution that's repeated. We'll call it a multiplicity of 2 or a repeated root. But if it's less than 0, I get 2 imaginary. So I get 2 imaginary. I'm just going to abbreviate imaginary IMG. And so this is where the quadratic equation comes from. It's taking this idea that we get 2 roots and we could factor, but sometimes our numbers aren't factorable or they're real numbers that have repeating decimals. And so this format will always give me the solutions.